Good morning, everyone. You're listening to the Sci Files, an exposure segment featuring Michigan State University student research. We're your co-hosts, Chelsie
and Daniel Puentes.
Today we're joined by Lili Gloe. Lili, can you please tell us about yourself?
Yep, so I am a third-year graduate student in the psychology program at MSU. I'm in the clinical psychology program, and I am currently a member of the clinical psychophysiology lab. And in that lab, we study a variety of things, but primarily my work focuses on how anxiety influences or is related to the way people think, learn, and solve problems.
When I hear anxiety, the immediate thing that first comes to my mind is the feeling that I feel when people describe anxiety. But can you describe what it means on a more physical level?
Yeah, so I can talk a little bit about how my lab and I generally think about anxiety. So typically we think of anxiety as comprised of two different components. So the physical component that you might be thinking of where you feel your heart race, or sometimes people feel like they get sweaty or things like that. We think of that as something called anxious arousal. So it's kind of like if anyone has ever had panic attacks, that kind of fits under that category. It's that very physiological type of anxiety. The other type of anxiety that we typically think about, and one that's of particular interest to me, is called anxious apprehension. And another word for that is worry. So most people have been worried at some point in their lives about something, but it's really those like what if thoughts that come up. So it could be like, what if I don't pass this test? What if I don't have enough money to pay my rent? All sorts of thoughts like that kind of spin around in our head. And if you're someone with an anxiety disorder that involves worry, those kinds of thoughts can feel uncontrollable, like it's hard to stop having them.
And what do you particularly study with anxiety?
Yep. So a lot of my work focuses on how worry relates to the way people, again, think, solve problems. And so the way that I study that is by kind of two different components. So to study the anxiety portion, we often are having people fill out questionnaires. And so people will come into our lab and fill out a bunch of different questionnaires that tap into some of those aspects of anxiety that I was describing. So we have a questionnaire that's specifically for worry, but there are other questionnaires that tap into the more physiological parts of anxiety too. The other component to what I do is assessing the cognition piece, or the thinking and problem-solving piece of things. And the way I do that is by having people complete different computer tasks that are meant to tap into different aspects of that thinking. So one task might, measure people's ability to inhibit or not engage in a particular response that would be kind of like a default response. So for example, like if you are told to only click a button when you see the letter X, but don't click the button when you see any other letters, that inhibiting response on the other letters might be something that I'm interested in. But there are a variety of tasks you can use to tap into different things. The other portion of my work involves recording people's brain activity when they complete those tasks.
Well, that was a really comprehensive overview of your research. Thanks for that, Lili. Something I think about is how do people extract numerical data from these qualitative research studies, such as your questionnaires?
Yeah, so the way this works is it kind of depends on the questionnaire that you're having them complete. Generally, the way that questionnaires are scored in psychology is that different numbers are typically assigned to different responses, and then you're able to sum all those numbers together or add all those numbers together in order to get a score. So for us, a higher score might mean that someone is higher on one of those types of anxiety.
Something that really caught my attention were the tasks that you were mentioning that people do on the computer. What sort of things are you looking for whenever you give these people certain tasks to do on the computer?
Depending on the task, sometimes we're looking at how fast people are responding to certain, letters or different stimuli we might show on the screen. Other times, we're looking at how accurately they're able to do those things. And depending on the task, there are different constructs that we might be looking at. So I'll give you an example of one. So there are a whole group of tasks that are meant to assess how well people are able to hold things in their memory and then continuously update what's in their memory over time. So that might involve a series of letters being presented one after another, and you need to make certain responses based on either the letter that's being shown or a letter that was shown previously.
And to also touch base upon something that you mentioned earlier, you mentioned brain activity, and that's something that we're really interested in. We once had an episode about neural implants in the brain, actually. So, what do you do with brain activity?
So the way that the brain works is that there are electrical and chemical processes going on all the time in the brain. And the way that I measure brain activity is by tapping into that electrical activity that's going on. Everybody has electrical activity going on all the time in their brain. One way to measure the electrical activity is by using something called an electroencephalogram or an EEG. You may have heard of an EEG. Sometimes they use them in hospitals. And then there are also a different set of EEGs that are used in research. But often when people are encountering EEGs, it's because of epilepsy or some other neural problem where they're in the hospital and they're trying to monitor their brain activity. In my lab, we use these research EEGs to isolate electrical activity during particular parts of the task that we're looking at. So for example, we might want to know when a certain type of stimuli is shown during the task, what does their brain activity look like? So you may wonder why that is useful. And so the reason why we look at these electrical activity is because there are these deflections of activity or peaks in activity that have been shown in previous research, not done by my lab, but actually by many, many labs over several decades, to show that there are certain electrical signals that are associated with certain of those thinking processes that we're interested in. And so by looking at the brain activity, we can then get more information than we just get from performance. Because sometimes the things that we're interested in terms of looking at how anxiety is implicated in those thinking processes might not be observable in behavior, but we might see differences in brain activity that could be important.
If I consider the area where my face is as the front of my brain and the opposite side of my brain being the rear end, what side of the brain is activated whenever people are feeling anxiety?
So actually, anxiety has not been shown to be in a particular area of the brain. And so there are many different brain areas that are implicated in anxiety kind of distributed across. So one of the reasons why I study the way that anxiety impacts these thinking processes is because we know where those thinking processes are kind of electrically on the scalp. And so we can then use that to see how anxiety impacts those processes because we know where those are located.
And what do you do with the data after you find out that there's differences with electrical activity and whenever the brain is activated by anxiety?
So this is a really great question because I think there are different ways in which other researchers use this data. And I think my lab is in contrast to some other ways that this kind of data is used. There are definitely other people using this data in similar ways, but I will kind of draw a distinction between two different ways you could use the data. So the way that my lab is interested in studying this process is by understanding kind of from a functional standpoint, how is anxiety implicated in these processes? So we're less interested in understanding how is like an anxious brain different than a non-anxious brain, just clear cut as kind of like a biomarker or for identifying someone who's anxious, but rather, which is the other way that people tend to use this data, we're more interested in how is the anxious brain working.
When I think of the brain, one of the things I think about is how brain waves are measured by different research groups. Does your research lab look into how the brain emits these brain waves? And I have zero knowledge really about it. Could you explain a little bit about what that is?
Yeah, so we don't really study like the neural basis of those signals. Other people do, you're right. But our lab typically doesn't look at that. We typically take the work of others, which indicates that these certain types or timings of brain waves are associated with certain thinking processes, like that inhibitory process I described, or maybe with a making of an error. There are certain signals that are associated with making of an error. And then we use that information then to relate to how anxiety is impacting or is related to those signals.
So then is a brainwave simply just an electrical chemical response that you see?
Okay, so the electrical activity that we're able to measure using an EEG is actually the summed activity of many neurons or tiny cells in the brain working together to create a very large electrical event that is coordinated.
So you could think of it as being something similar to like an earthquake. Whenever the event happens, the waves travel through the ground and we're able to detect them with our seismometers, but instead of seismometers, you use an EEG.
Yes, that's right. And in an EEG, that wave has to be large enough that we can see it, which is important. So it has to involve enough activity that we're able to measure it through our thick skull.
So then what exactly is your lab measuring whenever you're looking at the EEG in the first place?
Typically in my lab, we study electrical activity that is time stamped or kind of bookmarked with a computer task event. So that could be the making of a response. That could be when they see a letter or another stimulus appear on the screen. It depends on what we're interested in.
Are there specific brainwaves that you're looking at for this, or are you looking at overall?
We look at a variety of them depending on the project. One of our favorite signals to look at is one that is generated when people make errors. It's called the error-related negativity. It is a negative deflection of electrical voltage activity that occurs about 100 milliseconds after you make an error. And it occurs whether or not you realize you make that error or thinking about that you made that error.
I've never heard of that brainwave. Usually I hear about like alpha waves or like the brain waves that are involved in like sleep and stuff like that. What other ones do you look at?
So there are a variety of these voltage deflections. They're actually called event-related potentials in my field. That those time-stamped electrical activity, and there's a lot of different ones. There are ones that specifically are thought to respond to faces. My lab doesn't really look at those, but they're pretty interesting. So they get larger for faces. There are ones that are specific to semantic violations. So like if you're expecting someone to say, if you say hot, you might expect someone to say cold, but if they instead said, I don't know, excited, you might feel like that was kind of a violation of your expectation. You would get a larger signal for that than if they said cold. So those are some examples. My lab is really concerned with the ones that involve, again, kind of the thinking processes like the error-related negativity or the ERN that I described earlier.
This is all really cool, but I'm curious, what are the implications of your studies?
So what we hope is that we're better able to understand people who are anxious, understand the way that thought processes might be related to anxiety, either that anxiety is influencing these thought processes or that certain ways of thinking are actually risk factors or predispose people for having more anxiety. By better understanding how anxiety works for people, how it works in the brain, how it works in the way that we think, we hope that we could develop theories that would help us better understand anxious people and then hopefully inform treatment down the line to be able to target those weaknesses that people who are anxious may have in these thinking processes in order to boost them and maybe help reduce some anxiety.
You said that your lab is studying the brain activity with anxiety, but even if you knew the specific types of waves, how they were being manipulated, and the amplitude, how would you be able to intervene then?
The waves tell us something about the way that thinking processes are working in people who are anxious, in addition to task behaviors. They're both equally important in telling us about how that person is maybe going about these thinking processes during the tasks. If we knew which thinking processes were maybe more linked to anxiety, we might be able to try to make efforts to bolster those. We also might be able to use what we know about these relationships as a way of seeing if current interventions are working to target those processes, because it's possible that current therapies or current medications that are being used right now in those with anxiety disorders could actually be affecting those processes, but we don't know because we don't know enough about the way that this is working yet. Typically, we're studying everyday people in our lab. The reason why we do study everyday people in our lab is because we're interested in looking at anxiety as a dimension or along a scale. So when we were talking earlier about using questionnaires to kind of some scores together and then give someone a score that represents their anxiety, you can then imagine that if we did that with a lot of people, we would end up with people all along the continuum. So people who don't feel that anxious, mostly people who feel a little bit anxious, people who feel really anxious, and so on. So in some of our studies, we do control for people who are on medication, but in a lot of them, we would take anybody who is willing to participate because we want to understand, again, that whole continuum.
Whenever people hear the word anxiety, there's this negative stigma that comes along with it. Whenever you think of somebody that's having like a mental breakdown, it's always this negative feeling that's always associated with it. What can you say about that, about the stigma of anxiety?
Yeah, I would definitely say that anxiety is something I think about every day because of my work. And I can tell you that everybody experiences anxiety at some point in their life. There are people who are more anxious than other people, but we're all, again, along that continuum. So what I would say is that there are many resources. If you are a student on MSU campus, there are many resources. If you are the kind of person who's more anxious than not and you're really struggling in terms of schoolwork, in terms of your relationships, if anxiety is impacting your well-being, or it's just making you feel not that great, there are a lot of different things you can do. So there's CAPS on campus, which is a great resource for students and offers free counseling to students. There's also a variety of other resources locally that exist for psychological and psychiatric services. So that involves both therapy and then medication. So I would definitely encourage people to seek those things out. I would be willing to guess that at least one person you know has sought out those resources in your life. And so it's definitely great to keep the conversation going with those around you because you might not realize that someone you know really well is also struggling. I think that there is a stigma out there, but I think that it is changing and people are becoming more open to talking about these things. And even if you're someone who doesn't feel comfortable talking about these things, just know that it is okay to have anxiety. It's a normal part of life to have anxiety. But I would also encourage you that if you are someone who is really struggling to get through the day, if you're someone who's really weighted down by your anxiety and you don't know where to turn, definitely consider seeking services. I think that most people, once they are in those services, realize how many other people are seeking those services as well.
Yeah, I agree, Lily. It's really important to have this kind of conversation about anxiety and to help shed away that negative stigma that it has already. In regards to other work, we recently had a clinical psychologist be interviewed on our show in the past couple of weeks, and she shared with us how she is involved with clinical work. Is that also a part of your PhD experience as well?
Yes. So I also do see a small caseload of clients, but I want to make sure that I say that I am supervised by a licensed clinical psychologist in the area, so I am in training. But that is part of my program and my training is that I get to work hands-on with some really lovely people and learn more about the things that I'm studying, but also, learn more about how to help people.
And then are you involved with anything else on campus?
So I am involved in MSU SciComm on campus. And other than that, a lot of my activities take place within my program, so serving on various program committees and things like that.
And what is MSU SciComm?
MSU SciComm is an organization that educates researchers on how to talk about science, but also engages in science policy work and outreach in the area.
Great. It's important to be able to work with these people that are doing the research to be able to communicate their information to a form that's digestible with the public audience, a lot like what we're doing here with this radio show, trying to translate people's research into a way that is understandable by anybody that's tuning in to listen. But thank you so much, Lily, for coming in this morning to come talk to us about your research. We really do appreciate it.
Yeah, it was great to be here. Thank you.
Thank you to all of our listeners that joined us this week. And remember, the truth is in the science. Any comments and questions can be directed to scifiles@impact89fm.org. We'll see you all next week on Sci Files.